Very fresh good morning everyone. Welcome back to another session of your science class, and in today's session we will begin with a new chapter Motion and Time. So let's begin with the definition of motion. Let us consider this point as any fixed point, also called reference point. REFERENCE reference point, and let this be a flying bird. Now, if you compare the position of this flying bird with respect to the reference point, you will observe that the position of the bird is changing, right? First, this bird was very closer to the reference point. Then after some time, it is at a distance from the reference point. The position of this bird is changing. It is changing with time. It is changing with respect to the reference point. Hence, I can say that the bird is in motion. Right? Any object is said to be in motion if its position with respect to a reference point or time changes. On the other hand, let us again consider this as any fixed point or the reference point, and this is a tree. This is a tree. Now if I compare the position of this tree with respect to this reference point, you will observe that the position of the tree with respect to this reference point does not change at all, right? If the tree is at this distance from the reference point, after few minutes, it is again at the same distance from this reference point. After few minutes, it is again at the same distance from this reference point. Means the position of the tree is not changing with respect to this reference point or with respect to the time, and hence the tree is said to be at rest. Any object is said to be at rest if its position does not change with respect to a reference point or time. Now let us talk about speed. Let us try to understand what is speed. Some objects move faster than the others, right? For example, an aeroplane is faster than a car or a motorboat, while a car or a motorboat are faster than a bicycle, right? Speed is actually the measure of how fast or slow an object is moving. Speed tells us how fast or how slow an object is moving. For example, let there is a race between two students, Ram and Aman. There is a race between Ram and Aman, and it is observed that Ram covered a distance of 18 meters in 1 minute, while Aman covered a distance of 20 meters in 1 minute. So whom do you think whose speed is more? Obviously, speed of Aman is more here, right? Aman covered more distance in 1 minute and Ram covered comparatively less distance in 1 minute. Aman covered 20 meters in 1 minute while Ram covered 18 meters in 1 minute. Here the distance covered in unit time is more in comparison to the distance covered by the Ram in unit time. Hence the speed of Aman is more. Hence speed can be defined as the distance covered by an object in unit time. More the distance covered by an object in unit time, more will be its speed, and less the distance covered by an object in unit time, lesser will be its speed. So speed is the distance covered by any object in a unit time. Unit time can be 1 second, 1 minute, 1 hour or any other unit. So we can represent the formula of speed as distance travelled upon time taken. Speed of an object can be measured in several units. For example, like speed is equal to distance upon time. If the distance is measured in kilometer and the time is measured in hour, so the unit of speed will be kilometer per hour. If the distance is measured in meter and the time is measured in second, so the unit of speed becomes meter per second. If the distance is measured in meter and the time is measured in hour, so the unit of speed becomes meter per hour. In this way, speed can be measured in several units. But the SI unit to measure speed is meter per second. Meter per second is the SI unit of speed. You may have seen a device in every vehicle that shows the speed of a vehicle. The speed of moving vehicle is recorded and displayed using an instrument called the speedometer. SPEEDOMETER, speedometer. There is another instrument called the odometer that is used to record the distance travelled by the vehicle. Instrument used to measure distance travelled by a vehicle is odometer. ODOMETER, odometer. Now let us do some numericals on speed. But before doing numericals, you should know the formulas to calculate speed or distance or time. Let me tell you an easy way to learn the formulas of all three. Make a box like this, a triangular box like this. Write here S, here T and here D. D stands for distance, S stands for speed and T stands for time. If you want to find the distance travelled by an object, simply multiply these two. So the formula of distance is speed into time. Next, if you want to calculate this, means if you want to measure the speed of an object, divide these two, distance in numerator and time in denominator. So the formula of speed is distance upon time, or I can say distance divided by time. Next, if you want to calculate the time taken by an object to cover a distance, So time is equal to distance upon speed. Distance in numerator and speed in denominator. Hence the formula of time is distance upon speed. Speed is equal to distance upon time. Distance is equal to speed into time, and time is equal to distance upon speed. So now let's do some numericals. So the first numerical is calculate the speed of a bus that travels 130 km in 2 hours and 10 minutes. Here the distance travelled by the bus is 130 km and the time taken by bus to cover this distance is 2 hours and 10 minutes. Now in order to calculate the speed of bus, we must convert this time either entirely into hours or entirely into minutes. Here it is easy to convert this time into minutes. So let us convert this timing into minutes first. 2 hours is equal to 120 minutes, right? Because there are 60 minutes in 1 hour, right? So 120 minutes in 2 hours plus 10 more minutes. So the timing or the overall time taken by the bus to travel this distance is 130 minutes. Therefore, speed is equal to distance upon time. Distance is given 130 km and the timing is 130 minutes. Right? 130 divided by 130. So I get 1 km per minute. Hence the speed of bus is 1 km per minute, which means that the bus is traveling 1 km in 1 minute. Again repeating, if the speed of bus is 1 km per minute, it means that the bus can cover 1 km in 1 minute. Second numerical, a man starts from his home by a car at 9:30 and reaches his office at 11:30. If he covers a distance of 100 km, calculate its speed. Here, a man starts from his house at 9:30 and he reaches his office at 11:30. So the time taken by this man to travel, time taken is equal to 2 hours, right? And the distance between his house and office is 100 km, right? Therefore, speed is equal to distance upon time. Distance travelled upon time taken. Distance is equal to 100 km and the timing is 2 hours. 2 divided by 100, we get 50. So the speed of his car is 50 km per hour. 50 km per hour, which means that he can cover a distance of 50 km in 1 hour. Now next question, calculate the time taken by a car to travel 150 km if the speed of the car is 30 km per hour. Here the distance travelled by a car is equal to 150 km and the speed of a car is 30 km per hour, and we need to calculate the time. Therefore, time is equal to distance upon speed. Distance given is 150 km and the speed of a car is 30 km per hour. So, on doing calculations, we get 5. Kilometer will cancel kilometer and the unit left will be hour. So the timing or the time taken by the car to travel this distance is 5 hours. Next, express 144 km per hour in meter per second. Means we need to convert this unit of speed into this unit. Let us do 144 km per hour. Here kilometer needs to be converted into meter and hour needs to be converted into seconds. 144 and this kilometer can be converted into meters. 1 kilometer is equal to 1000 meters, right? So I can write here 1000 meters. Similarly, this hour can be converted into seconds. 1 hour is equivalent to 3600 seconds. Now after doing calculations, I get 4 into 10, 40. So I get 40 meter per second. Hence 144 km per hour is equivalent to 40 meter per second. Now next question. Convert 10 meter per second into kilometer per hour. Means we need to convert this unit into this unit. Meter needs to be converted into kilometer and seconds need to be converted into hours. So let's do 10 meter per second. Meter can be converted into kilometer by dividing it by 1000, right? And second can be converted into hours by dividing it by 3600. So this can be written something like this: 10 divided by 1000 upon 3600. And now applying mathematics here, if I convert this divide into multiply, then this will become reciprocal and it can be written like 10 multiply 3600 upon 1000. Now calculating it, I get 36 km per hour. Hence 10 meter per second is equivalent to 36 km per hour.